Okay, so this is prep test 79, game one. So our scenario says in 1 week, Monday through Friday, a library's book mobile will visit 5 of the following 6 neighborhoods. It gives us our variables. And exactly one neighborhood will be visited on each of the 5 days, and none of the neighborhoods will be visited on more than one day. Okay. So this is a very simple ordering game. That's all we're doing right now. We're just ordering. So I'm going to write down our variables, which is H, L, N, O, P, and S. And then to order this, we know that we have Monday through Friday. That's when they're being delivered. So we're going to do Monday, Tuesday, Wednesday, Thursday, Friday. Now this game is a little bit special because it says that we're only visiting 5 out of our 6 up here. So that means that there's going to be one that's not included. You can do this a variety of ways, how you want to kind of showcase that. The way that I'm going to do it is I'm just going to put a line here. I'm going to do X, and that just means like we're not going to visit. Just it doesn't really matter how you kind of notate that to yourself. You can even just kind of go through it without really thinking about what has to be out, but this is how I'm going to do it. Just so I can see when I do go through the questions that, let's say if N is in, then it could be true that P has to be out. It's an easy way of looking at it without having to do a whole lot of mental gymnastics. So, okay, so this is my setup. This is what we're going to do. So rule number 1 says H is visited, but not on Friday. So we know that H has to go in here. So it's not going to be in my X'd out spot. So we know H is going to have to go in here somewhere. That kind of leaves a lot of room. So even if I don't do it on Friday, I still have 4 other spaces that H could go in. I could split up worlds in this way. I could do a world where I have H on Monday, H on Tuesday, H on Wednesday, and so on. But that's a lot of different worlds, and especially since it's just rule 1 and we have 3 other rules, I think I'm going to save it for now. So I'm just going to write to the side because I know that H is going to be over here. I'm just going to kind of write it to the side and notate to myself like it's on this side of my column. But I'm going to wait until and see if there's something a little more restrictive that I can kind of put my H in where I'm not really making 4 different worlds right off the bat. So, okay. So rule number 2 says if Old Town is visited, then it is visited on the day immediately before H is visited. Okay. So when we talk about if-then statements in a logic game, there's really only 2 possibilities, right? If this is happening, then we know what happens. But if it doesn't happen, we don't necessarily know what happens. There's only 2 options. It either does happen or it doesn't. So either O is visited or it's not. And that's kind of how every single if rule is when we do a game, is it's either happening or it's not. If the if statement is going to happen or the if statement is not going to happen. So right off the bat, I'm going to split this where one world O is happening and another world O is not happening. And every time we make a new world, we're going to copy it exactly down. So we know H can't go here. We know H is in there. So I'm going to choose number 1 to be my world where O is not happening. And number 2, I'm going to choose to be my world where O is happening. Now, because the part that says, so in world number 2, we know that O is happening. And that's what our sufficient condition is in our rule 2. That's when we know what happens. This is where the rule is applying. So I can actually automatically just kind of merge this into my diagram. So when O is on this side of my diagram, then it says that it is visited on the day immediately before H is visited. So rather than writing like O underneath H or something, I can just automatically know that O and H are going to be right next to each other because O is in this side. So this is a good place to do some breaking of worlds because it's giving me a little more an idea of where I could put H. It's restricting it a little more. So because O and H have to go directly as it's laid out, I can just kind of move my block as I'm going down my line. So I know that O and H can start on Monday. I'm going to create another world and move my block down that line until I can't move it anymore. So moving O and H down the line, I could have O and H on Wednesday, and then I'm going to move it down the line again. Monday, Tuesday, Friday. And I'm going to move that O and H down the line again, which would then put O and H on Wednesday and Thursday. And that's as far as I can go with O and H because I can't have H on Friday. So there's only a few spots that I can put O and H, which helps significantly. Okay, cool. So let's move on. So that was that rule completely in its entirety. We can move on to the next rule, which says that if L is visited, then it is visited on Wednesday. Okay, so brand new rule. We're going to go all the way back up to world number 1. World number 1, the rule says if L is visited. So again, another if statement. It's either happening or it's not happening. So in world number 1, I can't have it be that L doesn't happen because I already have O not happening. So that means L must be in this. This rule has to apply to this world because I can't put L on the outside. The math doesn't work with that. So because I know that L is being visited, then I can automatically put L on Wednesday because that's what the rule says. Cool. Moving into number 2, I can have either or happen. Because there's no spot on my not happening side, I don't even know what to call it, but on my not happening side, I can have L on either side of my diagram, basically. So I'm going to make that happen. We know, well, oh. So we're going to have a world where L is on this side and where L is on the other side of the diagram. So I'm going to make my world 5 be the world where L is not happening. And over here, I'm going to make it be where it is happening. And when L is visited, the rule says that it must be visited on Wednesday. So I can just automatically put that in there, it happening on Wednesday. Okay, going down to rule number 3, we can kind of shortcut this, very similar to rule number 1. Again, if L is being visited, there are 2 possibilities. L is either visited or it's not visited. But in this world, world number 3, I have something taking place in my W, and if L is visited, then it has to go on Wednesday. So if L is on this side of my diagram, I'd have to put it on Wednesday, which can't happen in this world. I've made it so it can't happen. So that way we know that L actually cannot be visited in this world. L has to go on this side of my diagram. And that's very the exact same in our other world, world 4. Because I have O on Wednesday already, I can't put another one on Wednesday. So that means that L can't happen, because if it is happening, it would have to go on Wednesday. So that means that it actually can't happen. So L actually has to be on our non-visited thingy. Okay, cool. So we have L placed. I'm just going to cross out what I have already placed. I have O placed, and I kind of have H placed in all of them. Kind of. Whatever. Okay. So that was our 3rd rule. So our last rule is N and S are both visited, but not on consecutive days. Okay. So brand new rule. We're going to go all the way back into our world 1. We know that N and S are both visited, so we make sure that they're both on this side, which actually has to happen because O is the one that's not being visited. So we know that we have N and S, and they cannot be on consecutive days. So we can't have them touching. It can go back and forth. So we can't have N and S, and we can't have S and N. They cannot touch each other. With this world, I think it'd be easy to break it up just for a more visual approach to it. I think I'm gonna break it up where we place H. Because H goes into only 3 spots in this world, I think that'll kind of help us determine N and S because they can't touch each other, right? So let's make that happen where we place H in our worlds. 7. So we have O not happening. We have L on Wednesday. Okay. And because H can't go on Friday, we're going to make a world where H goes on Monday, where H goes on Tuesday, and where H goes on Thursday. Okay. So now let's look at it. If H is placed, we have N, S, and P. Those are the ones that are left over in 1, 6, and 7, the worlds that we have created from this first one. If N and S cannot touch each other, that kind of dictates where N and S kind of has to go. Because we have 2 spots that are touching each other, we know that we can't have N and S in either, or N and S together in those spots. So P actually can't be on Tuesday because if P's on Tuesday, there's only 2 spots for N and S to go. So we actually know that P is going to go in one of these 2 spots, Thursday or Friday. So I'm going to do this. That arc just means that it flips back and forth. So P could go on Thursday, P could go on Friday. And then because N and S can't touch each other, and those are our only 2 remaining variables, I know that they can interchange with one another. So I'm just going to write something like that. Works. And since that was our last rule and that diagram is completely full, we're going to check mark it because it's completely done. I don't have to worry about it anymore. I'm going to move down to 6, which was the other copied world that we had. And it's going to be very similar to number 1. So because we know N and S cannot touch each other, and because there's a spot where 2 of them are touching, we know that our other remaining variable P has to be like the breakup between the 2. We can't have N and S on Thursday and Friday. So that means that N and S can't be on Thursday and Friday together. That means that, again, P is going to have to go on one of these, and N and S is going to fill in our other spot. That's good enough. And last rule, our variables are placed. We can check mark that. Going on to world number 7, again, we have N, S, and P as our remaining variables, and because we have 2 spots that are touching, we know that one of them has to be P, and N and S kind of fill in our other spots that are open. So long as they're not touching, we're good. So again, we're good there. Okay, so we have 1, 6, and 7 done. We'll move on to world 2. So again, we have N, S, and P as our remaining variables that we have to place. And the only 2 remaining spots that are on our visited diagram are actually touching one another. And so because of that, we know that N and S can't both be visited, because if they are both visited, they'd have to be touching one another, and that can't happen. But because the rule says that they are both visited, I can't have something like this, right? Because they both have to be in there. So this world actually is completely eliminated. We can't have this world happen, because the only way for N and S to both be in there and for all the other rules to occur, N and S would have to be touching one another. So we can cross that one out. Yay! Okay, moving on to world number 3. We know again N and S cannot be touching one another, and our remaining variable is P. And so because we have 2 spots that are touching one another, P is going to have to interrupt that, because if we had P on our Monday, N and S would have to touch one another. So we know that P is either going to go on Thursday or Friday, and then we can fill in our variables N and S on the other open days. And again, this is a full world because we have all of our variables placed, and it was our very last rule. Going over to world 4, again, we have 2 spots that are touching. And so because we only have 3 variables left, P is going to have to interrupt that spot. So then our variables that cannot touch one another are spaced apart, basically. So we're going to do the same thing. We're going to do a little arc that says can go in or P can go on Monday or Tuesday, flipping with N and S. And N and S are going to fill in on that Friday as well. I'll look really bad. Ugh. Okay. Cool. So pretty much up until this point, all of the worlds have been very similar. We have 2 spots that we have to break up. World number 5 is a little bit different. We actually have 3 spots that are consecutive and that are touching one another. So because N and S cannot touch one another, we know that there has to be something separating them, which means that P is going to have to go on Thursday, because if P goes on Wednesday, N and S are touching one another, and if P goes on Friday, N and S are touching one another. So in order to split N and S up, P has to go on Thursday, and then I don't really care where N and S goes. There's nothing that's really restricting me, so we can just flip-flop with those. And that's the game. So that is the entire setup. So let's go into our questions. So number 1 is just a list question. It says, if 5 neighborhoods visited by the bookmobile are listed in order Monday through Friday, we have to figure out which one it is. So as a typical list question, we're just going to go through our rules and eliminate the ones that are violating, eliminate the answer choices that are violating the rules. So our first rule is H is visited but not on Friday. So I'm going to go down and make sure H is on here and make sure it's not on Friday, which eliminates E. It is in there, but it's on a Friday, so we can eliminate E. Next rule says, if Old Town is visited, then it is visited on the day immediately before Hidden Hills. So every time we see an O, we have to make sure that H immediately follows it, which eliminates D. If Lakeville is visited, then it is visited on Wednesday. So we're going to go through and make sure that Lakeville is on Wednesday if it's in there, which eliminates A because it's placed on a Tuesday. And everything else is good. Going on to the next rule, it says N and S are both visited, but not on consecutive days. So let's make sure that N and S are both in there and not on consecutive days, which eliminates C. So our answer is B. Okay, next question says, get my thing all set up. Okay, next question says, which one of the following neighborhoods cannot be visited on Thursday? So I'm actually going to go through my worlds, or I'm going to go through my answer choices and make sure that if I do have it in my worlds, it's wrong, because I'm looking for something that cannot happen. So if it's happening, it's wrong. So for example, A says Hidden Hills. Can I have H on Thursday? I can have H on Thursday, so I can eliminate that one. N, well, I know that N, P, and S can flip-flop on Thursday just based off of this world. So I know that any one of those 3 can actually happen on Thursday. So I can actually eliminate N, answer choice B. And furthermore, I can eliminate D and E, P and S, because I know that they can both switch. Which leaves me with C, Old Town. And that actually, yeah, that has to be true, because if O is in there, it has to, or H immediately has to follow it, and we know that H can't be on Friday. But we also know, because of our diagrams, we don't have one where O is on Thursday. So question number 3 says, if Hidden Hills is visited on Monday, I'm going to pause there. I'm going to see where it's happening that Hidden Hills is visited on Monday. It looks like it's only happening in World 1. So this is the only world where I'm looking at when I'm going into this question. Which one of the following must be true? So this has to happen in this world. It must be true. It can't be a flip-flop. It can't be a could be true. It has to be true. So does it have to be true that L is visited on a Wednesday? In that world, yes. Yes, it does. I'm going to go through the other answer choices just to make sure. N is visited on Tuesday. Well, because it's a flip-flop, it doesn't have to be true. It could be true, but it could also be true that S is on Tuesday. So therefore, it's wrong because it's not a must be true. P is visited on Thursday. Very similar. P can flip-flop between Thursday and Friday because of my arc. So while it could be true that P is visited on Thursday, it doesn't have to be true. So we can eliminate that one. S is visited on Tuesday. Same explanation for B. N and S can flip-flop, so it could be true that S is on Tuesday, but it doesn't have to be true because we could have N on Tuesday. And then very similar for E, S is visited on Friday. Actually, 3 different variables could be visited on Friday. So because it doesn't have to be true that S is on Friday, that one is wrong for this question. So our answer choice on this question, question number 3, is A. L is visited on Wednesday. Okay, question number 4 says, if Hidden Hills is visited on Wednesday, which one of the following must be true? So another must be true. So I'm going to look for where H is visited on Wednesday. That happens in World 3 and only World 3. So this is the only world that I'm looking at, and we know that it's something that must be true. Does it have to be true that N is visited on Monday? No, it does not, because it can flip-flop with S, so we can eliminate that one. Does it have to be true that O is visited on Tuesday? I'm liking that one. It has to be true that O is on Tuesday. There's nothing else flip-flopping with it, and there's no other world that I'm looking at. Does it have to be true that P is visited on Friday? No, it could be visited on Thursday because we can flip-flop them. S is visited on Monday. Does not have to be true because it can flip-flop with N. And E, S is visited on Thursday. Does not have to be true because we could have P on Thursday. P, N, and S flip-flop on those 2 last days in that world. So our answer choice is B. O is visited on Tuesday. Next question says, if N is visited on Thursday, I'm going to pause here and I'm going to look at my worlds where that's happening. That could happen here. If N is visited on Thursday, then we know that P has to be visited on Friday because they would flip-flop, which would force S to be on Tuesday because we have to pick one of them and the other one is filling in my other spot. So it can happen in World 1. It can also happen in World 3. We can have N on Thursday, which would mean that P goes on Friday and forces S to go on Monday. So that could happen there. Could also happen in World 6. We could have N on Thursday, P on Friday, and S on Monday. And those are the only 3 worlds where this could happen. So we're looking for something that must be true. Okay. Just looking at my thing. Automatically just kind of looking at my diagrams, I'm noticing that it has to be true in all of my worlds where P is actually on Friday. Nothing else is really standing out to me that's consistent in all of my 3 of my worlds. So I'm going in predicting that P has to be on Friday. So we're gonna go through our answer choices. Does it have to be true that H is visited on Wednesday? No, it actually happens in 2 of my worlds where L is on Wednesday, so that does not have to be true. Does it have to be true that L is on Wednesday? No, there's 1 world where I actually have H on Wednesday, so that does not have to be true. O is visited on Monday. No, actually, that actually cannot be true at all if N is on Thursday, because we're either going to have H or S visited on Monday. So that one's just automatically out. D, there's my prediction. P is visited on Friday. Yes, because it's happening in every single one of my worlds where I'm being constrained. So I'm liking D. S is visited on Tuesday. Nope, actually, I only have that happen in one. It doesn't happen in all of my worlds. I actually could have H or O on Tuesday, so that one is eliminated. So my answer choice is D. P is visited on Friday. And that is the game in its entirety, including questions and setup. Hopefully this helped. Let me know if you have any questions about this game though.